Hi, my name is Bob Tracy. I'm a senior software architect at the Institute for Quantitative Social Science at Harvard University.
And hello, I'm Ellen Kraftmiller, a software engineer, also at IQSS.
Okay, and in addition, we've been working with SPARC for a few years. We've worked with Mesos Cluster Manager and Standalone Cluster Manager, and we've been interested in ways of easily scaling up and down our application, and that's what has brought us to be interested in working with Kubernetes as a cluster manager. Last year, Kubernetes just came out as a fourth cluster manager with SPARC in the 2.3x versions, and we did a little presentation about that. And so we're going to pick up from there what's happened with 2.4, what's coming up in SPARC 3, and then we're going to also talk, a lot of our talk is going to be about something else, which is a SPARC operator for Kubernetes, which came out around the same time as the SPARC implementation, but it's just started to get used in the last year or so, and that's probably the biggest new thing in the last year that we're going to be talking about, and we're going to be giving a demo based on that. One thing else before we get into this is we want to know, so who here has a lot of experience on Kubernetes but not so much on SPARC? A lot of experience with SPARC, not so much on Kubernetes? Okay.
Okay.
Very good. Okay, very good. Go ahead.
Okay. Before we get into the details about SPARC and Kubernetes, I wanted to tell you a little bit about what we're developing at IQSS and why we find SPARC useful and why we're evaluating Kubernetes for our SPARC application. And so we're building a tool called Consilience. It's a web tool for social science researchers, for any researchers that are interested in analyzing large quantities of text. And so the idea is that a social scientist who's not too comfortable with running, clustering algorithms or statistical models on their own, to use our application, they can upload their data sets, and then we run a whole series of analyses on their data and present it back to the user. So here in this right-hand screen, you can see that what this is showing is different term frequencies broken down by part of speech, and on the bottom here, we're showing some sample classifications that we ran on their document set. A k-means clustering, and also an LDA topic model. And so in terms of our application architecture and what happens as the data goes through our system, we have our Consilience web application. The user uploads the data, we save that data to an Azure blob, and then we kick off our SPARC job to do all the analysis. And that SPARC job runs NLP processing. It runs various k-means algorithms and LD topic modeling with different parameters. And it saves all that data into a Mongo database, and then it presents it back to the user. And as this is a web application that we're intending, different people to be uploading, we want to have our system be able to handle multiple jobs at once, and also handle jobs of varying sizes. So if they have a large document set, we want to be able to scale up as the load increases. So right now we're running on a SPARC standalone cluster, but we're looking at Kubernetes because we want to be able to really use our resources efficiently and to be able to scale up as necessary. So now we're going to get more of a deep dive into SPARC and Kubernetes.
Right. So we're not going to a real deep dive into SPARC, but I just want to, for people who are not at all familiar with it, this is boilerplate. SPARC is a fast and general engine for large-scale data processing. The Kubernetes support started last year with 2.3x. The main thing about SPARC is that it can run MapReduce type of stuff 100 times faster than Hadoop when running in memory, and when writing to disk and using a lot of disk usage, it's still 10 times faster. This is a basic picture of the cluster execution. You have a driver node, and a bunch of worker nodes that are running tasks in parallel, and not just two, of course, many running in parallel, and that's part of what makes it, part of MapReduce and what makes it work real fast. These are the basic SPARC components. Everything with a kind of bluish color comes with SPARC, and so that means SPARC SQL for query, streaming, machine learning library, and GraphX for network type of analysis. The SPARC core, which is where the engine resides, the way that they handle data and resilient data, distributed data sets, and data frames and all that kind of stuff like that. Standalone cluster comes with SPARC. A lot of people, because they're coming from Hadoop, might use the yet another resource negotiator, which is a Hadoop-based cluster manager, and Mesos is another manager that was built around the same time as SPARC by the same people as SPARC. And as I said again, Kubernetes came into the SPARC environment in the last year or so. It was working on for before that, but the last year that was actually released. So Kubernetes is about container orchestration. It's like an operating system for clusters. Simplifies application deployment, improves utilization of resources, and becoming a standard for running distributed applications, and runs using containers like Docker in particular and others. The thing that we are interested in running in the cloud is the ability of cloud environments to automatically scale the Google Kubernetes engine, which is where Kubernetes comes from, and Google Compute Engine, but it also Kubernetes runs with Amazon Web Services, and we actually use Azure. We use Azure Kubernetes service. So again, version 2.3 of SPARC, Kubernetes 1.6 or greater. Right now, people, I think AKS is at 1.14, others are at 1.15 at least, and Docker are like the main elements of running it. So this is the basic way of running SPARC on Kubernetes. You have a client that will submit a job to an API server. The API server, starts up a driver and executors that are going to run the tasks in parallel to make the computations that you want to make. The client can be a command line client. It can be a Java application, Python application, R application, or Scala. Although, as we'll see, some of those have only come in the last year or so. Initially, when it came out, it was basically either command line or Java APIs and things like that that could run the SPARC submit. So that's one long command line, and that just for people who aren't familiar with SPARC, that's what goes into a SPARC submit. You point to a master. That master doesn't exist anymore. That's from last year. You can deploy either having the driver running on the cluster or running locally in a SPARC application or the command line desktop. There's a label for the application that you're going to run. This is a typical example, SPARC-Py, and it's bundled in examples.sparkpy. In this case, we're kicking off 5 instances. The image is a Docker image that I built to run specific things. Add some things for the SPARC analysis. Setting up a service account, name SPARC, and then the jars that the application runs from, and a parameter to the SPARC-Py program. So SPARC 2.4. When 2.3 came out, as I said, it did not have the Python support. That's been added. R bindings have been added, so now you can run this with Kubernetes. You could always run SPARC with Python and R, but not on the Kubernetes cluster manager. When it came out, you could only run the driver in cluster mode, so running on the in the Kubernetes cluster. Now it runs in client mode as well, and it also brought support for mounting Kubernetes volumes. Futures, some of these were futures last year as well. Some of them are a little bit new, but for dynamic resource allocation and external shuffle service, local file dependency management, SPARC application management, and job queues and resource management. SPARC 3.0, when we first, if anybody's familiar with the process of submitting for Code 1, it was submitted many months ago, and we were hopeful that SPARC 3.0 would be available, but it's not yet available. At least my last check was late last night, and it had not been released. But there's been a lot of talk of it over the last year or so, and some of the things that I know are ready are marked as resolved and are ready to go. Our pod templates, which is going to be related somewhat to what we're going to be talking about in a few minutes in terms of the SPARC operator. GPU-aware scheduling, so that you can make pods run on GPU nodes. Subpath mounting, in other words, now when you mount volumes, you can only mount a root volume, but they're added subpath mounting of volumes. Improving behavior with dynamic allocation and integration testing improvements. Those are some of the big categories. There's many more. There's probably 100. You go into JIRA and you'd find 100 issues and new features that have been, and improvements that have been resolved or are at work. So now we're going to talk about the Kubernetes operator for SPARC, because that's probably the biggest thing that has come about in the last year. So a Kubernetes operator is something that for generally any like when you run in Kubernetes, generally the scheduler is going to send things, without any work, the scheduler is going to send things, build up pods, put them in, some place, but they're not necessarily going to be, optimized for the way that your application runs. So as you notice, for instance, in that little simple diagram that I show with the driver and the executors, naturally you would like to have them running, co-located, so that communication between pods and stuff like that is not going to slow down the application. And that's just one example of what an operator can do. And databases, anything with any kind of stateful behavior needs a little bit more information than just throwing it on a Kubernetes cluster and running on whatever pods that get selected. So it was built for the Kubernetes, Google Kubernetes engine. It's a Google product. Oh, and by the way, before the operators themselves were a product of a company called CoreOS. They first developed a couple of operators called etcd and Prometheus, and Prometheus is actually used in the Kubernetes for logging and monitoring, something like that. And but it runs on any Kubernetes above 1.8. And as I said, we're running it on AKS, and we're running it on 1.14. I think Google, last time I looked, was at 1.15. Again, supports 2.3 plus, so it supports what was built last year. And it allows for more customization of SPARC pods. For instance, in SPARC, you have SPARC EMV and SPARC defaults and things like that, and a lot of things that are normally on your file system that you would be easier to be deployed within the pods and understood by the pods, and that can be done using this optional feature called a Kubernetes mutating admission webhook. That's so the Kubernetes runs on 1.8. The webhook, you need at least 1.9, but again, we're well beyond that in the environment that we're working in now. So here's an architectural diagram of the Kubernetes operator on SPARC. And the right side is kind of like the first diagram I showed you of the regular SPARC submit application. But here you have a YAML file that has some definitions of the SPARC application. You create a SPARC application using the YAML file from using either kubectl or SPARC CTL, which I'll talk about a little bit later on in the talk. So a SPARC application gets created. The SPARC operator is that little blue stuff in the middle of the square that's, that has the controller that detects that a request has been made to start an application or, stop an application, et cetera. The submission runner is what actually creates a SPARC submit, like that big, long command line thing that I showed earlier. The submission runner will pass what it gets from the SPARC YAML, that, parameters for making a SPARC submit. SPARC monitor will keep an eye on the state of the pods and report back. And that was one big thing we noticed when we were playing around with it last year. Is, excuse me, go.
Does every request map to a SPARC submit?
Excuse me?
Does every request to the service map to the SPARC submit?
Yes, when you deploy the SPARC application, it does translate into a SPARC submit.
Yeah, but I mean, every time you perform a request, when you use the service, you're performing a SPARC submit for the job.
What kind of request? You mean to start to run the job, you mean?
You showed the web service that you had in order to perform an
Right. Oh, I say yes. We would kick off a job.
Every time you do that,
Yes, we do a SPARC submit to run a SPARC application.
then I have a second question. In terms of performance with Kubernetes, how much time did that take in order to spin up all the executives? Because the SPARC submit is going to trigger.
Right. Well, that's what we're just evaluating Kubernetes. We're not actually running on Kubernetes right now. We're running on standalone cluster. So. Okay.
Yes, and if we can,
we have a demo where we can show you
I think
it
we have
spinning out.
we're probably going to end up from our dry run. I think we'll have about 10 minutes for questions maybe at the end. So if we can keep it to that. So again, so we had the submission runner, the SPARC monitor, and as I was starting to say, when we first were playing around with it last year, we had a Java application that would run several different SPARC jobs in sequence, and some were dependent on another one. And so we were very, we had a way of in the Java API of getting the status of the job that was run, when it was finished, et cetera. And that wasn't there with the first implementation of Kubernetes. But the SPARC pod monitor, and we looked and we saw that there was a way that you could do it in Kubernetes. And that's basically what the SPARC pod monitor is doing now. It detects the state of pods as successful, failed, that type of thing. And then again, the mutating admission webhook for doing things like mounting volumes, et cetera. And then the rest of it is pretty much the same thing as the other SPARCs. And one other thing that when we're running this, generally you're going to have role-based access control running, and so you have to set up a SPARC account, set up a cluster role binding role, and those type of things to run the jobs, so that the driver can create the executor pods. Custom resource definitions. This is what you use for setting up the applications in a SPARC application. I mean, in a SPARC operator. There's two basic things. One is a SPARC application, which is a basic kind of on-demand application that we're used to running, or also you can have a scheduled SPARC application, which is run like on a cron type of schedule. And again, you can use kubectl or SPARC CTL to kick off the YAML file to kick off the application. Here's an example of a spec. The first three sections there are what you'll have, whether it's a Cassandra or a Postgres or anything like that, SPARC operator. You'll have the API version of the SPARC operator, the kind of application it is, in this case a SPARC application, and the metadata, which is a name, a label for the application running, and a namespace for running. And then under the spec section, for whatever, this is particular to running a SPARC application, type Scala, role, mode cluster, or client. The version of SPARC that you're running, the full name of the application that you're running in the jar that it's running out of. Oops, did I do the wrong thing? And so again, mutating admission webhook is optional, so it allows you to customize the SPARC driver and execute a pods, Kubernetes 1.9. If you already have a SPARC operator running, you would use kubectl with a file a YAML file that starts up the SPARC, enables the SPARC operator. If you were installing with Helm, you use a parameter set enable webhook equals true to add this optional feature. And again, the use of it, you can mount a config map, so that can be like the SPARC env files, your Hadoop configuration files. You can mount volumes for writing to, and you can set up pod security context and things like communicating with DNS server and that type of thing. And another thing, as I was talking about before, the feature in Kubernetes that allows this, some of the application behavior called tolerations, and tolerations are a way of making it so that only certain types of pods are running in a given node, and that, that could be necessary in any given stateful application. And pod affinity is something that will allow you to group pods on a specific node together again. So you like to have all the executors running together because there are things like, I don't know if it was part of your question, and it's also not well developed yet, but shuffling in the application and things like that would not be hard if they were, just on random pods in a Kubernetes cluster. And SPARC CTL is basically, it's kind of like an extension of kubectl. It has, flags and hooks into the Kubernetes, the namespace and the Kubernetes config. And an example, again, is mounting. You can use it to mount a local Hadoop configuration as a config map in Kubernetes. If you search for SPARC and Kubernetes, you'll find about 15, 20 different things, but these are a couple that seem to us to be most related to the kind of stuff that we're talking about. Tomorrow there's something called Getting Started with SPARC on Thursday, and there's also something on writing a Kubernetes operator. So those are two sessions you might want to look into. And this one already took place, data pipelines with Apache SPARC, but you can probably go back and look at the, it might be recorded, or you can look at the slides and things like that and take a look at that. So,
And then, okay. So that's what we have.
That's our presentation, and we're open for questions, and don't forget to make out your surveys. But any more questions? Maybe we could use the mic there. Yeah.
Basically, I'm just wondering about monitoring when it comes to the SPARC workers. Did you guys use any sort of tool in order to collect
You mean
logs?
monitoring on Kubernetes? Or?
I didn't hear you.
Well, we use the SPARC,
SPARC
UI and the SPARC UI.
Okay.
Yeah.
So you didn't use any sort of Elastic, Kibana, that sort of stuff in order to collect some data regarding what's going on.
Right.
The
No,
workers?
we're still like in development mode and things like that. So we haven't gotten to that level of production.
You might want to consider it.
Yeah.
Because I've worked with SPARC, and eventually it becomes some sort of black box in terms of you're wondering what's going on the side of the workers, and the UI is not always enough if you want to really know what's taking time and why something is failing. So the challenge of collecting the logs into
Right.
some scalable monitoring stack is definitely. So I was just curious if
Right.
you guys tried to tackle that, because
Yeah, we
that
haven't-
was a bit of a complicated topic when we tried to tackle it.
Yeah.
That's it.
Yeah,
I think in
okay.
relation to that, when I was looking into it, because the Spark operator is pretty new to us, you know, and one of the things we saw was that people, I guess, collect things using Prometheus, which is one of the original
Yeah.
operators.
It's one of
Yeah, and there's connections between the SPARC operator and Prometheus that you can set up. So,
Okay, thanks.
okay, thanks. Anyone?
Any other questions?
Okay. Great.
Well, thank you very much.
Thanks for coming. Enjoy the rest of the